Cool. Okay. Let's see. My plan on Tuesday is to start going over ideas for the final project. It might actually be worth going over a bit today, but I will send out, let's see. Let's go ahead and yeah, why not? Why don't we do a bit of that today? So I'm going to go into my folder and then I'll start sharing my screen again. Okay. I'm just closing up things that I don't need. Okay, GitHub. Yeah, share screen. All right. Notes. Portfolio. Representative documents. Best projects. readme.txt. All right. I'll send this out for on via announcements later. But I do want to just kind of show you vaguely what some of the best projects in the past have been. Now again, the incentive for I am very lenient when grading these projects. Last semester, I think I only gave the distribution for people who actually turned in stuff. I only gave out a single C. Nobody who actually turned in something got an F or a D. 1C, handful of Bs, majority A. Okay? Majority were 90s. Okay, so I just want to emphasize that. The various projects we have here, again, if you can tell by the titles over here, we have a bunch of people who, we have all these different kind of projects that run the gamut. I have organized them very roughly. What I'm gonna do is I'm gonna grab a couple. Okay, and these are projects that have won the best project. Now, I choose at least one from every section, at least one project. Okay, typically I do at least two. About 15% of the class typically gets exempted. So this one was a project.
Hello, my name is Ryan Schwarb, and this is my final project.
Let's actually, hold on, stop share screen, share sound.
My final project consists of 3 things that are usually really tedious to do in genetics that I managed to automate to save a significant amount of time. So the first one is the chi-squared analysis. This is able to provide a p-value, which is used as information on whether or not to reject the null hypothesis. In other words, it tells me whether or not the results given are as expected or not. This one provides a Punnett square, and this one provides a Punnett square which is able to tell me all the expected offspring from parents, right?
So this,
and I had
again, a bit. This is something very specialized for the student did for their own subject. Obviously, this is a student who's not a freshman, but that's we get a lot of that from students who we get a lot of science projects from students who are not freshmen because they have a project in their own major and they want to combine. So, this one.
Fine. So for this, I think the labels it has sad
So this person analyzes
or
it.
like was angry. So
So this one is emotion detection using neural networks. This is looks like it's done in Python as well. Okay, so a lot of these again, these are science ones. Let's see. Best project. Let's see another fun one. This one was really cool. Because I never really expect a turtle project to ever get best projects. This one was very, and a lot of these students, they did not follow the guidelines I had set out at the time for doing for limiting their time like to 3 minutes. This one I make a bit of an exception for because it does take a long time. What he's doing is showing how basically you can make pictures using string art. And then different amounts of resolution. So basically converting the new Stormtrooper helmet into this kind of circular string art. But basically, it's being able to turn any arbitrary picture and kind of use the turtle to do that, which is really cool. If you're much more into doing kind of on the art end of things or music end of things, this person made a
Hi, my name is Dexter Giglio, and my final project is an audio distortion VST plugin that I made using C++ and the Juice framework. So how it works is distortion is created through this function here, where I just made it. So S is the signal, and I just made it a sine wave for now because it's easy to see what's going on. So V is the volume slider, and D is the distortion slider. So, and then all it's doing is really just taking tan H of D of the signal. So let's see, we can see if I
go
increase
ahead
the
and hear
distortion
what it
amount,
looked. So
which is,
he built a framework.
and then I made
Or
sliders
built
are
it using
defined
the
here
Juice
in
framework.
This is that
And then
signal, right, and then here's it with the distortion, and then we can choose the gain. Here's
it looks
barely
like you're using
anything, and then you can really crank it too. And that's the end of the volume. It's already pretty loud. I'm not gonna turn too loud.
I can't.
Clip the recording, but
Which is the what is the what is the one that he's using? Not FL Studio. I can remember the icon. Give me a second. Winamp. I'm gonna remember it very quickly. Winamp was created by Justin Frankel, who then created Reaper. It's Reaper. He's been using Reaper. So he did this in Reaper.
here it is through his cabinet emulation. And I think it sounds pretty good. So yeah, this is my final.
So basically, his entire project took a guitar signal and turned it into an electric guitar, which is pretty cool. This one was pretty cool as well. It's one of those ones I can include in the portfolio, and so the 3 people watching or 2 people watching who understand this will be suitably impressed, and the rest of you will wonder what the hell is going on. And basically, this is mapping Bad Apple onto Idle. For those 3 of you who understand what's going on. Basically, it's doing it's a program to basically render Bad Apple. For those of you who don't understand, there's basically 2 kind of programs that are kind of guideline, or 2 kind of things that are guidelines in computer science. First off, if it's a computer, somebody's going to run Doom on it. Okay, the original Doom, right? This game, Doom. No, not Doom. Doom. Not that Doom. The original Doom. Oh, get out of the way. Original work. This Doom, the original Doom. It is very efficient game. Problems are basically modern computers are extremely powerful, so you can probably run Doom in it. In fact, one of the things you can do in games is figure out how to run Doom in that game. For instance, Doom in Minecraft. I made Doom in Minecraft with redstone. So there we go. So let's see. Doom in Minecraft. The other thing is that if it's a display, okay. The other rule is that if it's a display, it'll be used to play Bad Apple. Okay. Bad Apple on everything. Bad Apple, but it's our place. Which is basically people just putting pixels down. And this is just simply a timeline of that. The amount of coordination that required is astounding. And yeah, that was pretty awesome, I thought. Now this one was another favorite one of mine from last semester, the Goat Gate. This one was I'll let the student explain herself. This is like an ideal final project, I think.
Hi, Professor Rosen and TAs. My name is Rotem Schirmeister, and I will present to you my GoatGate final project. So I made this project to make sure that Fiona and Marceline will not run away and open the gate by themselves. So I created this project using a Raspberry Pi and magnetic switch. I configured the Raspberry Pi to run Ubuntu and used an SSH to code the Raspberry Pi in a heedless mode. I installed Python and GPIO packages to the Raspberry Pi. Also, I wrote a code that independently tests sending an email from the Raspberry Pi and detecting the change in the state of the switch, so if it's open or closed. I also troubleshoot the magnetic switch and learned the importance of the pull up and pull down resistors. I created an email and Python file, which was called in the main script, and I combined the email functionality with the switch detection. So that created an automatic method which would send an email automatically once the gate is open. So on the left here, you would see what is the subject and the body of the mail, and on the right, you can see the image that I managed finally to implement into the email. So let me show you how it all worked. So hi, I'm going to show you how my final project works. So here's my Raspberry Pi, and right here, and this is my magnetic switch, so now it's closed. And right back there, you could see the goatee. So this is basically the goat gate. This is the goat gate, and I'm going to open the door, and you would see how I get a notification on my phone. So right now I have nothing on my phone, okay? Okay, goat gate is opened. Now, look at my phone. Now I just got an email. I'm going to click on it. And you could see it says, "Who let the goats out?" And then Fiona and Marcy are, gate is open, so now they're leaving. So we out here. They're really out here, right? Right, girl? It works.
So that is an example of a gadget project, which I think gadget projects are very, very, very cool. In my opinion, you get a lot of good ideas for gadget projects where basically you build something. You don't. I'll go over a few other ones that I think are good. Here are a couple, and now finally games. There's going to be a lot of games for you to check out. A lot of different types of games that can be made. Let's go ahead and share my screen again. And make sure to share my sound. Okay. Second, I just remembered there was another checkbox. Optimize for video sharing. Share. All right. Hand Jam. This was probably one of my favorite games that have been made by students. Which is they did a very they did um micro games, which you'll see that they have a bunch of games in here, okay? But they're very small, very simple games, okay? Now, any of these games being programmed would get you basically an A, okay? Because micro games are games, okay? If you can make it playable and repeatable, then awesome, okay? Do that. But because of the way they formatted it, this was what got them a best project. Micro games, great things. Check out WarioWare if you haven't, in terms of what a micro game is.
Hello,
Hi,
I'm Michael Perino,
I am Merritt Hyman.
and we are freshmen, and this is our project, Hand Jam.
So they did this in Unity, and I want to emphasize that that if you couldn't figure this out, or if you haven't picked up on it yet, you don't have to limit yourself to Python. You can work in anything. This month-long final project is, I am giving you the excuse you need to learn that thing that you've wanted to learn for a while. So if you've wanted to learn how to get into video game and make games in Unity or Unreal Engine or Godot, this is your excuse to do that for an A, okay? That's what I want you to do. I'm giving you that excuse to learn that thing that you've been thinking about doing, okay? Take advantage of it.
I'll be providing the gameplay.
This is a 5-level little mini game. All the levels exist in the same space, and the camera, all of the like 2D objects are in a 3D space, and the camera basically just goes through them to switch levels. I wrote the music that is in the background, and I'm also the main character. I feel like some of the difficulties in this were definitely getting all
shown
the
this one in class,
animations
I
to work, and also to make all the like.
Okay, I believe I've shown this one in class. It's great. So let's see, another one, tank. Okay. This one is just a 3D tank game.
And also turret control with the mouse scroll wheel and shooting with the mouse scroll wheel.
This one was done by a
Then
former TA of mine,
I made
or a
this
student
terrain,
who went on to become a
had block
TA.
code textures, and then found a asset where this turret was like shaped up together, allowing for me to use it.
Okay.
The
Another
object
one.
Hi, my name is Gavin Montross.
Hello, my name is Logan Kraus.
We are both freshmen, and our project is a 2D roguelike game called Cosmo Runner. We made it in the Godot engine. We took heavy inspiration from games like Risk of Rain and Bravida.
We took the time to implement a lot of cool features. Some of the
Now
features
I don't know how much of a tutorial they watched and followed for this one, but you can do that.
include robust player movement, challenging enemies,
What a
randomized
sound.
levels and chest loot, proper level transition logic, and plenty more.
All right. Another one. All sorts of games. So this one was done in
So
Pygame.
it can be the character here, as you can see, is Dr. Rosen yourself. Hopefully it's not too inappropriate. I hope you find it amusing.
I always find it
Now, the
amusing when
character
students use me as an asset.
here, I have it jump automatically, and now you can control it using the letter key A and D to
I
move
always
it
love these
left
kind
and
of
right.
bounce games because they're always a bit
And
challenging to do.
then
And then making sure you
once, as
generate
you
your
go
levels
up,
so that there's always a possible jump.
it will record your score and also show your score at the top of the bar. And in addition, it will also record your high score in a separate text file, which is really good, I think. So that way you don't need to remember your high score, and at the
Let's see. Which is revenge? Oops, copy.
This is
This is another a game made in Pygame.
what we have created is a 2D platformer. It says Witch's Revenge right here. When you click start, we have our little sprite here in our world and our background. the background is actually layers, so it does like give like a parallax effect when you're scrolling. It's not just a flat background, which is pretty cool. You can die, you can kill the enemies, and they will attack you. As you see, you have a health bar, and I believe I was. You can die and anymore. See, I'm still clicking the spacebar. And once you grab this box right here, your ammo will replenish. Time to make a second level, so when you get to the end, nothing really happens. Kind of just breaks a little bit.
Yeah, so he didn't finish the game. You know, he didn't make more than one level. Whatever. What I cared about is that you've got a working proof of concept. You've got basically a game. Now you just got to make the rest of it if you wanted to, right? This character, so whoever did this did a lot of good job work with the atmosphere for for horror, which I thought was very impressive. I'm always a big fan of seeing horror stuff. Because because you can make things scary, very interesting ways.
Hi.
This person,
While everything seems normal, one thing is off.
This person did a lot of
people in specific of my game Another World.
Did a lot of this one was done with in RenP, which is what I suggest for a lot of people to do. What really impressed me about this one is that this is a visual novel kind of style
another
game.
One of our mini games where you take the torn up shreds of the journal and recreate them into one full page.
I was so impressed when I saw this, which basically it's drag and drop stuff. Right? You can drag and drop these things and lock them into place. It's pretty cool. So I thought that was pretty fun.
Welcome to our final project in Unity. It's called Escape from Dynamo. Ripped off the Unity stores, thankfully. There's also a stamina bar.
Horror-based one.
But yeah,
and then some of them I just like because they're really interesting ideas.
Hello, Professor Simple, and then ouch. When you get hit, there's an audio file of me saying ouch, which I thought was fun to add, and then, you know, a death animation of a bunch of particles. So the grappling hook visually is pretty simple. It's just a blue line, but it was definitely...
Now, again, these are best projects. I don't expect this kind of performance from every student. These are just the ones that... But there's all sorts of games, okay? And I enjoy games. And I should mention, really, you don't really have to be good at anything to make games. One of my favorite examples is Undertale. Undertale is such an amazingly good game. And Toby Fox, when he made it, let's just say he made some extremely questionable programming choices because he was learning how to because he hadn't really done that kind of level of programming before. Like the entire dialogue is like one giant conditional statement. You know, but it had a lot of heart, and that's what makes it such a fun game. Finally, let's talk about this one. I think is just a good generic example of kind of this one is for a student who basically used their final project to make a very well designed web portfolio for themselves of their photography.
Overview, because initially I was going to put this carousel on the top above it.
So just a very well designed website with all their portfolio work. I've had students make websites for their family business or for a friend. I've had students make Discord bots. That's actually a really popular one, doing Discord bots. I'll go into more detail about different stuff as well as the way it works, as well as the way that, you know, different options on Tuesday, when I'm feeling not just a bit better, but a bit more organized. But I do want to, but I'm going to go ahead and send out these, this batch of work right over here so that people can see it. Okay. Oops. Yes. 1051. Previous best projects. Okay. Done. There we go. Okay. But an important thing, especially for any of the students who are juniors or seniors, okay, and you may have got, and I implied this, but I want to explicitly say so, okay. You're allowed to double dip. Now, in the student handbook, there is rules about double dipping. Namely, it's against the rules. It's considered academic dishonesty if you take, say, an essay you've done for class A and then don't change it at all and just submit it or barely change it and submit it for class B without telling anybody. Okay. Exceptions to this rule, of course, exist, namely when you get the permission of both professors involved. So I just want to be very clear about that, just so you understand that there is a rule there. But also, like, again, if you get the permission of the professor, then it doesn't matter. Okay. So what I'm saying is that if you have a final project in another class, and this is very common for your juniors and seniors, if you have a final project in another class and you can incorporate programming into that in some way, then I am more than happy to let you use that final project in both classes. So for instance, right, I did yes, that sounds very allowable. Come and talk to me specifically after class. But for example, I was doing my music, I had a final project in my music class, in my music theory 2 class, okay, to write some pieces, and I double dipped. I asked for permission and I double dipped. My final project, my capstone project, was working on a edutainment game, a educational game about asthma, right, as part of somebody else's research, right? So I was helping develop the game for them, and I did all the music for that, as well as some of the programming. But I did all the music, so I was able to count that for both of them. Okay. So that's the kind of thing there. So this is especially important to me for seniors because, you know, seniors have a lot of stuff going on and they're working on trying to make sure that they finish out their stuff. Generally, a freshman level class is the least of their concern. So I don't want to add any stress there, but also I'm a big believer in cross pollination between fields, right? So if you can think of some way to incorporate that, okay, then I'm more than happy to take a look at it. Okay. Right. We saw how, so I'd be we saw how basically there was a art program. We saw how there was, there were music programs here. Okay. So just to be very clear about that. Now let's get back now. Let's have some fun now. Okay. Not that this wasn't fun. Okay. Share screen again, share sound. No need to share sound now. Okay. We are just going to share my screen and we are going to go back to where we were when we were working on this stuff. Hopefully you've had the chance to watch these videos, by the way. If you've not, I think that this one by Mark Rober, he's done a lot of videos. Like he's like a very big YouTuber, okay? Like he's got a very big channel with a lot of science and engineering stuff like squirrel obstacle courses, porch pirate stink bombs, those kind of things. This one, he basically went to check out the games at carnivals, and basically the way he figured out the odds for like these physical games or approximated the odds was that he counted them. They counted the number of people he saw win and lose, right? So there's a lot of stuff over here for Monte Carlo approximations. So we're going to go over these things over the next couple days because I want to show you that basically math isn't that scary. Okay. And when it is, there's ways to cheat and make it less scary. Okay. I'm a big fan of doing things in a very clever manner to reduce the amount of work you have to do. Okay. Very big fan of that. Okay. So when we left off, we were saying that I was giving you a problem that I said come back to today. We have 7 cards. Okay. I'm going to lay down 7 playing cards 5 of those cards are black. 2 of those cards are red. I'm going to lay them face down in front of you, like so. Okay, lay them down in front of you. So, like so. And I want you to flip 3 cards, right? I want you to flip 3 of those cards over. If you can flip over 3 cards without a single red, then you win. Okay, you're going to win, let's say $10. But if you flip over a single red, okay, then I win the $10. Okay, so now the issue with this is that that I generally am not very nice about, or whoever proposes this game has generally not got your best interest in heart, because they'll say something along the lines of, well, let's just count how many cards there are. There's 5 black cards out of a grand total of 7 cards, right? That's more than 50%, right? Easy to see. Then when you flip over 1 card, you're going to have 4 cards left, 4 black cards, and there's 6 cards total. That's also better than 50-50 odd. And then after you flipped over 2 cards, right, you've got 3 black cards, right? And we know actually that odd pretty easily. That's 60%. That's much bigger than 50%, right? So over here, you have much better than 50% odds for each of them, better than 60 in 2 of them, right? So very good odds all around. So obviously, I'm an idiot for proposing this game because you're going to win big, right? No. So what we're going to, so if you actually play this game, your odds of winning are approximately 24%. Now I'll go through the math. The math is actually extremely easy for this one, and I'll go through that in a bit, but but let's assume we don't know anything about dependent and independent variables in probability, because we probably don't. A lot of us haven't even taken calculus yet, right? That's fine. We don't need that. What we're going to do is we're going to do something very simple. We're going to instead just program this game in, okay? We're going to program this game, and we're going to just do something very simple. We are going to say, basically, we're going to play this game like 1,000 times, okay? And we're going to just count the number of times we win. And then when we're done, what we're going to do is we're going to print the number of wins, divide by the number of trials, right? And then what we'll do is we will multiply that by 100. And then I will do this. This part is completely unnecessary, by the way, the multiplying by 100. In fact, I'll keep both around so you understand where, so that those of you who are a bit behind don't get too intimidated, right? You'll see it's basically the same thing. Sep equals, here we go. And that basically means there'll be no space between between what we print out and the and this. Okay, and so we'll print out what our win rate is. And obviously, since we haven't played a game and haven't won at all, obviously we've got a 0% chance at the moment. So let's go ahead and program the game. Now, a lot of this game involves choosing things at random. So we're going to need, for basically doing any kind of these random games, we're going to need to import random. Okay. Now so basically we need to, so let's think about what a game is, right? Let's just think about what a game is. Def game. We don't really need an input necessarily, but what we need to do to play a game, we need to create a quote unquote deck of cards somehow. Okay. And then we need to shuffle it. And then we need to choose 3 at random. So let's go ahead and just start even simpler. Let's go ahead and just make a deck of cards. Def make deck. Okay. And that's going to return a deck of cards, 2 red, 5 black. That was what we said. Now, we have different ways of doing reds and black. we could do like zeros and ones, but honestly, Python is really good at doing stuff, and memory is cheap, so we're just going to use strings. And so what I'm going to do is I'm going to say my deck is equal to, and we've got, I could write it out like this manually: red, red, black, black, and do and do it like that. Or I can say, whoops, red times 2 plus black times 5. And we'll just simply call this so that we can see that what I'm doing, right? And there, I've got a unshuffled deck, right? It's not shuffled. Now, give me 1 second. I'm feeling a heck of a lot better, by the way. I'm just still very congested. Very congested. And I'm not sure if I'm still contagious or not. Probably not, but it's just a very nasty cold. I only just started feeling better this morning, so I didn't even think I'd be feeling this good last night. So, but just overall very nasty cold. Wasn't COVID, wasn't strep, wasn't the flu, because I never really had a fever. Okay. So anyway, so as I was saying, Python's pretty awesome. Generally with random, it just gives you functions for generating random numbers. But Python, its random library is like the best. Okay, I want to shuffle a deck of cards. How do I do that? Well, it turns out random dot. Do you have autocomplete? Yes, you do. We have all sorts of stuff over here, including, we saw one pop up, random.shuffle, which does again, Python is all about doing the least surprising thing. Shuffle a list X in place, return none. In other words, it doesn't change it up. Now, so now what we'll do is that if I run this a few times, you'll see over here in my output that the positions of everything changes each time I run the program. So now we have a shuffled deck of cards. Okay, now, so we now have a shuffled deck of cards. Okay, so def game is, we're gonna be basically, the first step of the game is that the con artist gives us a deck of cards. That's not the part of the con. He gives us deck is equal to make deck. He gives us our deck of cards. And now we've got to choose 3 cards at random. Now, actually, no, we don't have to choose 3 cards at random. I just have to choose 3 cards, right? And obviously I can't choose the same card more than once. Okay. Otherwise I could just flip over a card and flip it back and flip it over, and, keep revealing the same card. That'd be a fun way to solve that problem, but you can't. Now, this is probably the one bit of statistics that both makes sense but doesn't make sense, which is that it doesn't matter which 3 cards we choose as long as we're just choosing all 3 all at once, right? As long as we flip over 3 cards, it doesn't matter which ones we choose. Okay, statistically speaking, if we play this game lots and lots of times, it's not going to matter. Specifically, if we just simply flip over the first 3 cards again and again and again, I'm always going to choose the first 3 cards. Okay, always going to flip them over, right? Then if I play a bunch of these games, it's going to be statistically, my chances of winning are going to be whatever the actual chances of winning are. Does that make sense to anybody? Did I lose people there? That does not matter which 3 cards I flip over, right? Because all I could do is just simply reshuffle everything and just put those until I'm happy with the first 3 cards. unknown cards being where I am, right? I could say, we could lay out the cards like this, and I could go, oh no, shuffle them again until these 3 end up in front, right? I don't know what those 3 are. Doesn't matter, right? Or shuffle until these 3 end up in front. I'm just gonna keep choosing the first 3 cards, whatever the first 3 cards end up being. Okay. So that makes this check actually very simple. And so this is probably the hardest part about making Monte Carlo problems, which is figuring out, oh, what is something can I make a choice that's always the same, and make it easy for myself. There are other ways to do this. And let's see. Okay, give me 1 second. I'll do it this way first, and then I'll check to see if there's any way we can do this with random to make it more like actually picking cards at random. Okay, so selection is equal to the first 3 cards. So that's just going to be a slice of the first 3 cards. And then we ask if, and so then we'll print our selection. Let's go ahead and remove some of the other prints we're doing, right? And change this over to game. Nope. None type is not subscriptable. Oh, right. Return deck. Right? You have to give it back. So now we've got red, black, black. That's my selection again. Huh. Always seem to be getting a red card in there. A lot of the time, in fact. All right. So we've got our selection, and we can basically say if are not in selection, return true. Else return false. We could actually simplify this. We could, instead of doing that if else block, I can just simply do this. Because if this is true, if this part is true, then I return true. So I could just simply directly return this. But again, keeping it simple here. So we play the game. So now what we do is that this part is basically going to be the same for every single Monte Carlo problem we end up doing, which is that we are going to create a for loop. I'm going to go ahead and grab the wins and trials over here, move them down here. For blank in range trials, so we want this loop to run trials number of time. If game, so we play the game inside the if statement. I know that's weird, but if game equals true, we get a true back from there. Wins plus equals 1, and that's it. Run. Invalid syntax. What did oh, why did I have a colon there? Weird. Okay. Oh, okay. I was wrong about the statistics. It's 28%. Let's run this again. About 28%, 30. The point is that the more times we play this game, the more trials we do, the more accurate our answer is going to be. Okay. If I play this go from 100 times more for 100,000, we get closer to the actual statistics, which is 28.7. Now, the actual answer for this is 5. I believe it should be 5 times 7 times, these are very familiar numbers, 4 times 6 times 4, 2 times 5. And there's our actual answer of our actual chances of winning. 28.5%, right? And our game is calculating it at 28.7%. 7%, which is pretty darn close, right? It's enough for us to tell we're not going to have a good time, right? Now, how did I figure that out? Well, I got these three numbers here, right? Where basically he was saying, well, the first time you go, you have a 5 out of 7 chance of winning. And the second chance, you've got a 4 out of, sorry, your second card, you've got a 4 out of 6 chance of it being fine. Now, now I was talking about dependent and independent variables. These statistics are dependent on each other. We can only go here to the second card if our first card is fine, right? And we can only go here if our second card is fine. These chances are dependent on each other. And in probability, that means you multiply them together to basically say, hey, for this to happen and for this to happen and for this to happen, you have to multiply them together. And that's how we get our actual answer. And we actually can just do this calculation kind of by hand, right? Two sevenths. Right? Just by simply doing some cancellation. But again, how are you to know this if you don't take a probability class? Right? Now, so the chances I got are very close. Let's go ahead and just double check one thing, which is I want to check Python random function, right? The Python random library generates pseudo-random numbers, right? It says don't use this for security. Let's see. DOS. No. Seed rand shuffle sample without replacement. Right? Okay. The other thing we can do is that we can do population. We can do this other function. Right? If we want to actually try, okay, what if we try drawing 3 things at random? We can use this function to say, hey, from the deck, choose 3 things at random. And we can run this program again. And you'll see we still get our statistics are about 28.5%. Okay. So generally speaking, so I don't know if it will be on the second exam, but always on the third exam and always on the final exam, there is a problem along the lines of a Monte Carlo problem where I give you a game or some rules for a game, and I ask you to not to calculate the odds, but to write a program to calculate the odds. Now I'm going to take a small break to get some water and cat tax, and then I will be back to go on and continue with our next game. right. So this is Molly. This is one of Murphy's sisters. Murphy, Molly, and my other cat Cinnamon, who you won't be seeing because she does not let me do this. They are all sisters. They're part of a litter of 5. When I was in grad school, we picked them up after they were born, and my roommate at the time took 2 of them, and my wife and I took the other 3. Those things on their face are sweat gland tumors. They are not painful. They're harmless. Just part of being old and part of different medical conditions she has, I think. And removing them is a bit tricky, so and not really worth the risk for her. But since they're painless and don't bother her, perfectly fine. And she's just such a, she just purrs so easily. When I pick her up, she basically starts purring. But she is nice, fluffy. She's a very much small. She's very fluffy and a lot smaller than her body implies. The fur makes her seem a lot bigger. I know. She spends a lot of time in the guest room bed. So whenever I have guests actually scheduled coming, I have to clean the sheets and then make sure that then they keep her from that room, because she loves being on the guest room bed. She's like, this is my bed. All right. Put you down over here. Maybe you'll stick around, maybe not. Okay. All right. Yeah. Cats are great. Cats are very great. They're less work than dogs, but dogs are generally a lot friendlier. Dogs are generally both are very good for your mood. Okay, if you can have one, a pet, a cat or a dog, but dogs are a bit more work than cats. Okay. But dogs are definitely more happy to be your friend, let's say. A lot of times cats just happen to live in the same space as you. Okay. Depends on the different cat, from cat to cat. Okay. They say this person, the thing you got to understand though about adopting an animal, okay, is that is a commitment for that animal's lifespan, okay? And it does mean you have to be that you will be having to say goodbye to that animal eventually. I had to say goodbye to my dog last year, and that was really upsetting. Because she'd been with me for longer than I had a kid. But pets are great. There are tons of there's tons of pets who need a home, and so if you can provide a home for them, they're gonna love you for it. Okay. So, all right. And if you can't provide a home, then animal shelters are always looking for volunteers. Okay. Foster, they're always looking for people who can foster until they can find a forever home. Okay. So, these are things that are worth doing. All right. So, let's go ahead and go to another kind of game. I did wear the Monopoly key paw for a reason. So let's go with exam to practice. There we go. This one is worthwhile, even though I do it in class. Right. So this was a problem I gave on the prior exam, and we'll go over it right now. So in the board game Monopoly. So first off, I want to point out this about Monopoly. So those of you who did not grow up in America, Monopoly is a very interesting board game. Right? Economics based board game, very themed about buying property and stuff. Right. part of the big thing about Monopoly is that a lot of people don't actually play it the way the rules say to do, because think about it for a second. You've played Monopoly before, a lot of you have you ever sat down and actually read the rules? Probably not. There's a lot of house rules for Monopoly and a lot of those house rules for Monopoly, they end up basically making the game go a lot longer. Okay. And but by making it so that people can stay in the game for longer. No, Monopoly is a pretty vicious knockout game. Okay. So now, one of the interesting rules for Monopoly is that there is rules for on how you roll dice. And a lot of what we'll be talking about over the next couple of days involves rolling dice, right? Specifically, we'll be rolling 2d6 or 2 6-sided dice, right? There's a nice dice notation, right? 2 6-sided dice. Okay. And that's how when you roll those dice, that's how you figure out how far you moved. So if I rolled this, right? If I rolled this, which is this 4 and a 6, I would move 10 spaces. Now, if on the other hand, I end up rolling, very luckily, right? Where I roll something like this, where I roll a 3 and a 3. 3 and a 3, there we go. 3 and a 3, right? That is, yeah, they shouldn't last 3 hours plus hours if you actually play by the rules. Okay. If you roll 2 3s together, you get an extra roll. Basically, you get an extra turn. Okay. Now that's a 1 in 6 chance of that happening, by the way. Because there's 6 different combinations for this one, 6 different combinations for the other one. That's so that's 36 different combinations, and of those 36 combinations, 6 of those are where basically the numbers end up being the same. So 6 out of 36, 1 in 6, right? So got a 1 in 6 chance of rolling 2 3s or 2 5s, right? If the player rolls another set of doubles while they're already on their extra turn, then they get another extra turn. So you can roll 2 doubles in a row and you get basically three turns in a row, 3 buys in a row, which is pretty cool. However, a third one lands in jail for speeding, right? When rolling doubles a third time in a row, you end up in jail for speeding. Okay. So now we want to know the odds, the breakdown of odds for each of these. Okay. Because like your odds of getting a 3 doubles would be 1 in 6 times 1 in 6 times 1 in 6. But I want to know what percentage of rolls will be 2 doubles and 1 doubles. Because a 3 doubles requires you getting a 1 double. So we kind of want to subtract these things out. So, and that's an interesting probability problem, but honestly, what we're going to do is we're just going to, again, write a program for this. Okay. So once again, I'm just going to work over in here, and I'm going to, instead this time, I'm going to basically create a roll function. Okay. To roll dice. Now, what we're going to do is we're going to roll a 6-sided dice, and there's a lot of different ways to do this. Okay. You could just do what we did here, right? Right? Which is not a great way to do it, but it would work. What you could do, right? You could totally do dice is equal to 1, 2, 3, 4, 5, 6, right? And then say random dot shuffle. And then to roll the dice, and then to roll it, we're just going to return, to figure out what you rolled, you would just simply return the first one. And that's statistically the same as rolling a dice, believe it or not, right? That's not a fun way to do it, but I mean, that's a fun way to do it, but not necessarily useful or really tell us use what we know, right? No, better to use stuff that's built into random, like random dot ran. So we've got random dot, and then there's a bunch of other functions in here, right? Randint. Randint is the exception to the rule for a lot of what for a bunch of things we're going to be doing. Whenever we did range or slicing, right, it was from A up to but not including B. With randint, this is the one exception to that rule, where basically we do where basically includes both endpoints. Oh, sorry, I'm so tired today. Okay, so 1,6. And let's just go ahead and just see what that looks like over here in idle, because that's part of why I love idle. We can test these things. Import random and random.rand int 1 to 6. Right? Copy, paste. Right? And it just generates a random number from 1 to 6. This will be good for rolling it up. This works for rolling a dice, right? Okay. That works for rolling a dice. And so we can just return that. Roll this number. Yuck. I think I have cat hair in my mouth. I wonder how that could have possibly happened, Molly. All right. Return random, not randint. And so that gives us our dice. Okay, so that is generally like when I'm grading these kind of things, when I'm grading these kind of problems, this is generally how I do this. And also, unlike the last exam, each of the problems in this exam, they come with a rubric. So I'm just going to pull up the other exam, the actual exam itself. I'm not sharing at the moment. I'm like, for the Monte Carlo problem, right? Like here, like for this, yeah, why not? So like here, like for this problem, this is from the actual exam, right? For the Monte Carlo problem, this is the rubric. I give you like, this is how I'm going to grade it and how I'm going to break it down. And when I do that, it also gives you kind of the breakdown of how you should be, testing for these things, right? First thing I need to do is figure out how to roll 2 6-sided dice. Then the next thing I should do is this. And the next thing I should do is the 10,000 rolls. Sorry, 100,000 rolls in this case. 100,000 games. Right? So, right? Another one. Is there another one that we can tell without actually? Nah, not really. Not really, no. But you get the idea. There's going to be rubrics for each problem on this upcoming exam. So now share screen again. Right? So. Okay. So first thing we want to do is now figure out is basically, let's go ahead and do Monopoly. Monopoly turn. Right? So D1 is equal to roll, and D2 is equal to roll. And what we're going to want to do is we're going to basically, I'm going to want to count the number of doubles, which I'm just going to call dubs over here because I'm being lazy today. Okay, and by default, we're going to return 0 dubs, right? So what we're doing over here is we are going to count we're just going to count the number of times where dice 1 and dice 2 end up being the same. Okay. So let's see. So there's a couple of ways we could do this. Okay, the first way we could do this is basically with an if statement. Right? We could do, hey, if double 1 and double 2 work out. So if they are, if D1 equal, if D1 equal, D1 equal D2, then what we're going to do is we're going to roll them again. All right. Yeah, D1 is E2. Then roll them again. And if they're the same, roll them again. And if we manage to do this 3 times in a row, return 3. Otherwise, we're going to return 2. Otherwise, we're going to return 1. That looks kind of funny. All right, if D1 is equal to D2, return 3. So roll them. And that's one way we could do this. And you know what? We'll go ahead and play with this for right now. The other way to do this, of course, is to make a loop that breaks early if they don't match. Okay, so let's go ahead and now make ourselves and do a game of Monopoly. Right, and what we're going to do over here is in our trials, what we're going to do is rather than counting our wins, we're going to count our we're going to count the number of outcomes. So let's create a list. Dubs is equal to index 0 means you get 0 doubles. Index 1 is basically rolling a double in a turn. Index 2 means you get 2 doubles in a turn, and index 3 means you got 3 doubles in a turn. Make sense there? And so what we're going to do is we are going to say, rather than doing an if statement and doing this over here, what we're going to do is the following. Same kind of generation for blank in range trials. We're going to do this trials number of times. We are going to say result is equal to Monopoly turn. That gives us a turn of doing Monopoly. And then we are going to, this is the weirdest looking part of this, and I apologize. Dubs result plus equals 1. Basically, right, this is going to return a 0, 1, 2, or 3, which will correspond to one of these indexes. That index is going to be used the number of times to track the number of times we got that result. So what we can do now is print for D in dubs, print D divided by trials. And we have, and this gives us our percentages, right? If I wanted to, actually, I can do this again, which will give us D 100 times to turn it into a percentage. And then sep equals. So an 83% chance of not rolling any doubles. And let's just double check that for a second, right? What is 1 and 6? 1 and 6 is 1.66. So 1 minus 1/6 or 5/6 is equal to 83. And this number. That seems about right. 833. Yeah, it seems right. This is the one that's going to be slightly off. So that's right for that part. So we can, of course, run this even more times and try to get even more accurate results. This will take a bit of time to run because it's taking about 100 times longer to run. Right? And that gets definitely closer to that. So figuring out the statistics of this, right, became fairly straightforward when what we ended up doing was just simply running the problem. Yes, you'll get a note sheet for exam 2. Now, let's see if I can do this or if it's going to hate us because it's a Python file. Okay. So drop this into Zoom chat. Chat. Is everyone in meeting? If you aren't here, well, you could look at the screen and copy stuff down. There you go. That is the code that I wrote down for the day. So you should have gotten that in chat. All right. And with that, I am fairly wiped. I'm going to go ahead and close the call. Okay. I'll stop recording. I'll leave the call ups to give you a chance to get this.